Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 52, we will cover urban freight planning, which is demand modeling. So, the different concepts that we will cover in demand modeling would be on background, the relationship among choices by decision makers and different urban policies, urban freight modeling framework, urban freight model classifications, then truck based versus commodity based versus delivery based approaches for developing urban freight models. Then we will detail out the truck based model and the commodity based model, and we will explain one sequential freight model which is particularly a commodity based model called freight sim. So, freight modeling is an integral part of transportation planning that we have learned from our previous lecture, and we have to estimate the present and future transportation demand, particularly freight demand, and there are different stakeholders involved that also we have discussed. But now what we will discuss is what kind of choices or what kind of decisions stakeholders make and which needs to be modeled actually, or we need to understand those particular choices. So, similar to urban area, there were household residential location choice, mobility choice, then there is vehicle ownership choice, then choice for mode, then choice for destination. Similar over to that, we also have different choice processes or decision processes which are involved in urban freight modeling, right. So, for inhabitants and customers, the first choice is buying location decision and mode choice decision. So, mode choice to go to buy something and also where to go to buy something. So, this actually determines the demand for a particular good in an urban area, and to maintain that demand we have to supply those particular areas with certain goods and commodities, and that is where freight is generated. So, you can and also when you buy something from somewhere you are not able to bring that particular good, the good has to be transported from that particular shop to your house. So, that is also generates some form of freight, but primarily the more popular a market is, more number of freights will go to deliver goods over there. So, inhabitant and customer choice for buying location do play a big role in determining the urban freight flows. Then the retailers, shop location decision and freight loading unloading decision, these are the two kind of decisions a retailer undertakes. One is where he locates its shop, and then what kind of loading unloading decision at what time of the day, how, where, is it just near his shop, is it far away, all these things play a role in the freight flows that originate. Then wholesalers, third party logistics and distributors, for them the choices is location choice based on retail market it caters to, that means where they will which market they will cater, that means not all retailers goes to not all wholesalers supply all markets, or not all third party logistic providers supply all markets. So, who goes where? So, those choices also play a role in determining the freight flows. Then the carriers, that means the actual vehicles which will actually carry the goods, for they will determine, or actually not vehicles, these are companies which may have multiple vehicles who are undertaking the final delivery. They are not the third party logistics provider. Third party logistic is one company, they may own their own trucks or they may not have their own trucks, they may even subcontract take trucks from some other agencies. So, they are the ones who does the connection process, and carriers are the ones who actually does the movement actually. So, decisions on delivery processes, that where to go first, second, or how to go there, all these things are also outcome of carriers decision processes. So, that also influence trip flows. And then we have got city administrators who minimize overall cost of the system, like urban distribution cost plus inhabitant transportation cost plus congestion cost and externalities. So, all this has to be a part of a minimization function which the city administrators will try to minimize. So that means it's not only reducing the externalities, congestion, and also transportation costs for shopping, urban distribution cost, but also they try to reduce the inhabitant transportation cost from due to shopping activities. So these all are linked together. So the different stages of freight modeling are production and consumption, that means how much is produced and how much is consumed. Then the trade, sales and sourcing, that means how goods goes from one point to another, and how do you distribute the goods and all, and then how do you get from where, and then the logistics part and the transport part and the network part. That means how do you organize your deliveries and all, then what kind of modes choices do you have, and how the network is getting loaded. So these are the different components that we need to study. So this particular image or this particular table is from a paper by KAM 2012, and there this actually shows the different choice dimensions, the different decision makers, as well as different policies that could be undertaken in an urban area. And not only that, the policies like time windows, weight constraints, emission constraints, road parking, shipment size, incentives, each of these policies are influenced by influences different stakeholders, and they also have a time horizon. That means these are the time horizon. So we can say this planning horizon is basically this one. So planning horizon is long-term capital investment, like long-term effects. So urban distribution center and transit point is a long-term decision. Who does it affect? It affects the acquisition zone for demand. That means where do you go for that, and then for the supply type, what kind of service has to be provided there, at what time, what kind of vehicle will be used, will it be a restocking tour or not. Restocking tour is that means one vehicle go and restock the different retailers. That means using one vehicle we can restock multiple retailers. So that's a restocking tour, or it depends, it could be just one vehicle restocking one retailer as well. So but it's a tour at the same point of time. So like I was talking about in my earlier lecture regarding that, okay, bottling plant sending soft drink bottles to different retail shops in an area, and once they go there, they will not only deliver, they will also pick up the empty bottles, and then they will come back to the same point, which is the bottling plant. So that itself is a restocking tour. So this is what is determined. So long-term decisions are where new infrastructure such as urban distribution centers, roads, and new vehicular and control technologies, these are we are concerned with these things. So these are long-term decisions. Then medium-term decisions are like loading and unloading zones, road pricing, and minor infrastructure changes that will affect freight flows. So these are medium-term decisions. And then finally, we have got short-term decisions, like we decide on the time window when we allow freight in a particular road, and that may be a temporary decision which may even change. So all these decisions, either long-term, medium-term, or short-term, has got different effect on the urban freight movement in or freight flows. So similar to passenger transport planning, we also have got long-term choices, medium-term choices, short-term choices. We also have same thing in freight as well. Long-term choices are like decisions on setting up my distribution centers or my freight terminals, or choice of those things. Whereas medium-term is where would be the loading unloading zones in a particular area, and then road pricing and all these things. So this the dimensions are more or less similar. The way we will plan the freight model is almost similar to the 4-stage transportation model. So again, in this particular image, we can see that this road parking and pricing affects what kind of service, affects which vehicle, and also affect the which restocking tour to take. So but it doesn't consider the time. That means if the parking price change with time, then this would have also have been a cross. So these tables actually summarize the connect between the different policies and the decision makers who are involved in this kind of decisions. Like we see, a retailer decides on a distribution center location, it also decides on a shop location and dimension, and it also decides on an acquisition zone. That means from where it gets those goods and all. So whereas a wholesaler they are not that concerned with about this acquisition zone, because they are actually just getting the goods from a distribution center, and the carrier is also not influenced by that. So all these things each has got their own domain which they are concerned with, and that has to be considered in the modeling process. Then this particular image shows the overall structure of the framework of the freight planning problem. So that means first of all, let us see, freight models should be able to forecast and perform certain kinds of activities like land use activities like business employment, housing and households, and transport performance like land use transport interactions like in LUTI models. So a freight model should be integrated with a land use transportation model. So that means decisions we take in the freight model actually influences location choices for business, location choices for households, location choices, and also the transport performance for the different land use transportation components, like it will affect the total impedance along particular corridors, it will influence more, and because of impedance change, it will influence mode choices, also for passenger transport as well. So all these things are interconnected. So that is what is being pointed out over here. So the freight model, so this part is more or less how it is integrated with the land use transportation system. Now in the next part, what we need to determine is the total quantity of freight, like what is the weight and what is the volume. Both are important. Why? Because weight and volume are two measures which has to be known when we decide on what kind of vehicles or what kind of truckloads that will be used by a particular restocking tour or in a particular delivery tour. So that means certain things may be of very little weight, but the volume is enormous. So you see that lot of trucks in Indian roads are overloaded, and the loads actually is much higher than the vehicle, and there is sometimes they are almost like shows that they are coming out of the vehicle. So that because they are mostly carrying a light good, and they have loaded the vehicle to up to its weight limit. So that's why that is actually creating such an that is changing more or less the structure or the profile of that particular vehicle. So freight quantity generated by end consumers, that means because of shopping, certain amount of freight has to be supplied. So we have to determine those things. And then distribution process of retailers, wholesalers and carriers, this has to be known. We also need to predict that. That means what is the most efficient process for distribution for a particular retailer, wholesalers, what kind of vehicle choice, what kind of tour choice has to be undertaken. So that has to be predicted by the model as well. Then transportation infrastructure and operation characteristics, they do play a role in the model outcome, and also we can change some of those to see how it affects the overall freight movement. Then multi-commodity assignment to network, like we have to assign our flows from different vehicles into the network and to see how it affects the overall traffic movement, how it increases the travel time, how it changes the link load functions. So we have seen those, whenever there is more truck vehicles or PCUs put, the capacity of that particular link is reached, and then there are certain other problems, congestion and otherwise that happens. So this is important. And finally, we have to have performance and impact evaluation of our plans. So over here in the image, you can see shopping actually generates the demand for supply. So shopping is the actual initiator for this particular process. It also influences the land use transportation choices, and that actually leads to activity system like inhabitants, retailers, distributors. So this shopping activity actually influences land use transportation location choices, because the far away you are from shopping, we have seen accessibility change for retail destinations, that influences your location choices as well. So that is how inhabitant housing choice is dependent on also their shopping decisions. Then retailers will also locate themselves based on access to markets. So that is why these things are linked, and same goes for distributors as well. For distributors, this is access to different markets, and retailers are location for the shopping centers. That actually is also part of this process. So because of the presence of these things, there is freight flows generated, and that is basically the demand. And this is where we simulate the freight transportation system, and once we do the demand, then we have this supply as well. That means we have to supply that demand, and for that we generate OD matrices, that from demand to supply how it happens, and from OD matrices we put it in assignment, and that means this has to be loaded into the link assignment process. That means once OD matrices are known, the total quantum of demand is that has to be supplied is known, and we can determine the freight flows, and that has to be assigned to the network, and then finally we have to do our evaluation. So this is our sort of 4-stage planning for traffic, this part. So this is generation, and this is the distribution, and this assignment process actually is sort of connected with the load pattern or mode choice as well, is also part of this process as well. So I will explain that in details. So we have got different kinds of urban freight models. So usually they can be classified as macroeconomic models, such as input output and spatial price equilibrium models. Like depending on the input output analysis, like when we talk about different sectors of the economy, then how much amount of goods goes from one sector to another, and that actually leads to formation of jobs, and also leads to formation of eventually the GDP of a particular urban for a particular country. And so this input output dependencies between different sectors leads to transit, or leads to freight flows. That means I have to supply so many commodities to another particular sector. So this actually leads to freight flow, and this kind of modeling is not that effective in the urban scale, but in the regional scale this is this is the only way to model. So that means to understand regional truck flows between different zones, we will use this kind of models, and we will discuss that in the next lecture. So multi-stage models, where we have, these are suitable for medium and short term planning, and these could be classified as, these are the similar to the 4-stage models that we have discussed for passenger traffic, and these could be classified as as per the quantity of delivery moved. That is, it could be primarily a commodity based model or a delivery based model. That means what amount of commodity is moving from one zone to another, or it could be based on the number of freight vehicles used. So we call it a truck based model, whereas for the first one it could be a commodity based model or it could be a delivery based model. So these are two ways to determine what kind of quantities or deliveries are happening. And then there are mixed models, which are mixed or hybrid models we can call them, which are commodity or delivery based. Both, there is a mixture of both, and then all these kind of models, actually there is a generation process, then there is a distribution process, and then there is a actual link assignment process. So as we just discussed. So based on the different techniques used, we can either go for growth factor kind of techniques that we have discussed earlier. That means we take the existing trip patterns and then we multiply with a growth factor, or we take the existing commodity flows, we multiply with a growth factor, and then we model for our future transit flows. But as you understand, that is not that, for cases when we have no data, it is fine. But if we have data to actually predict what changes will happen, then it's better to go for regression method analysis. So eventually we use a sequential model, a 4-stage modeling process, to determine our the total amount of goods that are generated as well as how they flow in an urban area. So looking at truck based models and commodity based models, truck based models are where truck trips are estimated, and these trips are estimated based on, like it's a regression model, like we were discussing on trip generation. Similarly over here, number of truck trips generated from a particular organization depends on number of employees in that organization. It could also depend on floor area of the organization. It could depend on the sale volume. So we have to do so these are the influencing or explanatory factors. So we have to develop regression equations to generate number of trips for a particular organization. So data requirement for this model is low and obtained from survey of truck trips. So similar to passenger traffic survey, we can estimate number of trips generated from different zones, and then we need to understand the travel times between zone to do a trip distribution model. And finally, once we do the trip distribution based on the observed truck survey data, we can also divide the truckloads into different vehicle types, or we can, when we develop a regression model, we develop it based on different truck wise. So once we do that, then we can undertake the assignment process. So models are sometimes calibrated as per type of vehicles, like light goods vehicle, heavy goods vehicles, and so on. So this is how we do a truck based model. In a commodity based approach, a quantity of commodity that is moved between each origin and destination pair is estimated. The commodity flows are eventually converted into truck trips, but we do the distribution using commodity. But once we know the exchange volume of this commodity, that has to be converted into truckloads, that is type of vehicle and their payload. So that means what kind of vehicle would be used to transport that particular commodity, and also what is the size of that payload. So commodity based models are more realistic and connected with the economy, because we can understand, because the economy influences the commodities consumed, and that actually is more realistic measure, whereas truck trips is just a factor which is we observe that this, which is a resulting out of because of certain changes in production or supply. So this is not directly connected with the economic development and all. So when we are developing freight models, they are very, very connected with economy. So commodity based models are the right way to go in that particular case. But as you can understand, it requires a lot of detailed input and output data, which is very difficult to connect because there is a lot of private sectors involved in this particular, in freight. All the different stakeholders are private entities. So that is the biggest challenge. So in commodity based models, truck traffic is forecasted based on economic growth and based on production and consumption of goods and services. So that is why commodity based models are more appropriate for developing freight based models, for freight models. Finally, we come to the delivery based approach. In delivery based approach, I will explain the figure as well, but first looking at the delivery based approach, the unit of analysis is movement or delivery, that is both pickup and the delivery itself. So we are predicting the flow itself, right? So that means a combination between OD two pairs and the flow, that actually is the outcome of my regression. So that is the decision variable. So unit of analysis is movement. Generators and transport operators are both connected because we are doing it based on the deliveries. Pickup and delivery, that is generation and attraction model, is a regression model. So this we predict the total number of deliveries, depends on freight type and type of activity and number of employees. So it depends on what kind of organization it is, it depends on what kind of activity that we are talking about and the type of freight. And flows that are predicted using these models are carried out using an aggregated multi-stage restocking tour model. That means the flows predicted as an outcome of this OD matrices are carried out using an aggregate multi-stage restocking tour model. Aggregate is because it shows zone-wise aggregation, multi-stage because different kinds of vehicles would be used, and restocking tour model means we will see that how those vehicles conduct their entire tour. So that means for the commodity flows would be modeled into, or these deliveries would be actually converted into different tours. So this we do for all categories of restockers starting from the same zone. That means different varieties of restockers are considered, and for each one of them we develop the model differently. And we also have got mode choice as an outcome of this. So in the vehicle based model, vehicle means truck based model, we have attraction and generation. That means number of trips attracted or generated, and then the total number of vehicles that are attracted and generated, and finally acquisition and distribution of goods, and which actually leads to vehicle OD matrices. Now acquisition or distribution is actually the flow or how the goods move from one zone to another. That is why it is acquisition or distribution. So somebody acquired the goods, and it is done through distributing the goods from the place where it is generated. So in commodity based model, again the quantity OD matrices are first formed, and then from there it is converted into quantity to vehicle, and then we get the vehicle OD matrices. And in delivery based matrices, this is delivery, each delivery trip is converted to vehicle, and then we develop the OD matrices. So, these are the basic difference between these three models. And in a mixed model, we have a combination of different things. We have attraction, we have attracted quantities to a particular zone, then what kind of distribution or acquisition we will do, then the transport service, that is what kind of delivery we will conduct, then we determine from that the OD matrices, the quantity to delivery, delivery OD matrices, delivery to vehicle, and vehicle OD matrices. Now, this is basically one model, but there could be other formats as well. So, this is just an example of how we can mix and match the different components of the other models. So, when we look at truck based models, area is divided first into geographic units, as you already know this. This is traffic analysis zones, and then economic variables are used for forecasting freight vehicle flows using regression. So, this is the next part, and aggregate data at the zonal level is sufficient for freight generation models, and freight flows originate and terminate at zone centroid. So, that means all the trips are assigned to a zone, and zone means a zone centroid. From there it will be they will be loaded to a particular network. So, this is the generation part. We use regression models. Then flow linkages between zones can be estimated using gravity model, where travel time or cost is taken as impedance, same as the passenger movement model. But this is where little bit of for passengers, we understand the distribution is like that, but we follows the attraction of a particular area, which is in term, and the impedance to it, like attraction is based on total amount of goods attracted and then produced. So, we use the same formulation, but sometimes it is a little bit inappropriate in case of this freight flows compared to passenger flows. The output from this step is and then finally we come to the modal split part, where in this we develop the multimodal trip tables. That means once we know the distribution of from which zone to which zone, how many number of trucks or of a particular truck type goes, then we can have the truck types as well, and we can determine the truck types earlier, or we can determine at this stage once we have developed the OD matrices as well. And then the mode choice decision is affected by some of the decisions. Why we can change the vehicle type is based on the type and size and value of the commodity, speed, reliability and capacity of mode, total logistic cost, that is inventory cost, loss and damage, service reliability cost, and overall logistic characteristics like length of haul and the shipment frequency. So, this is the decision parameter on based on which we will develop a mode choice model for freight. So, these are the different characteristics. So, it could be a combination of all these characteristics, or it could be a combination of some of these characteristics. So, this we can use for generating a mode choice model for a particular shipment. A discrete choice model is used for calculating the probability that each shipment will use a particular mode. So, that is same as a mode choice model we have done for passenger trips, we will also do a mode choice model for freight as well. So, then how do we determine these models? We of course have to do truck service, and from there we will estimate the different variables. We will collect data on that, then we will run our model, and then we will estimate the parameters. That means all the coefficients will be estimated from the model, and we will understand what influences what kind of vehicle choice. And freight flows are also converted eventually into truck flows using these payload factors, because each truck can only take a certain quantity, and that will be actually used to determine how many number of trucks would be generated. And payload factors are estimated from truck service and weigh bridge data. That means average amount of load in different kinds of vehicles would be determined from surveys, or if there are weigh bridges, we can take the actual data as well. So, finally, once we know that what kind of vehicle, what kind of loading will be there in each vehicle, how many vehicles would be utilized, we go for network assignment. And in this step, vehicular flows are allocated to predefined roadway network, use of capacity restraint assignment techniques, use of multi-class assignment, separate assignment for different class of vehicles, And road network assignment is dependent on the following factors like vehicular characteristics, time of the day factors, roadway capacity, volume delay functions, and truck prohibitions, because this all the things are common to for normal passenger assignment. So if you recall from our assignment lectures, these were the different, like we used a volume delay function for each link. Then we also considered the roadway capacity. These were influencing the volume delay function. Time of the day actually help us to divide the trips between different times of the day, and of course the vehicular characteristics, that actually what kind of load will be there in each vehicle and so on. So this actually is extra, this truck prohibitions, because when we are doing assignment based on the certain rules in the city, there may be some timing restrictions, or there may be restrictions of trucks of a certain kind in certain corridors. So these are the restrictions, or there may be some loading unloading time restrictions. So all these restrictions are in addition modeled in addition to the things that we have already done earlier. So this is almost like a 4-stage model. I have just detailed out the steps. You can also follow these steps to develop your own model. So commodity based model is more or less same. The basic structure is same, but here we estimate the truck OD matrices by commodity based on commodities. And so the attraction model, basically where we actually generate the number of commodity flows, like estimates commodity quantity flows attracted by each zone. This is again done through regression, where it's a linear function of socioeconomic data, number of clerical workers for that zone, number of workers. This is from an example, number of employees in manufacturing, population, and number of households in each zone. So it depends on what kind of zone it is. So these are the regression parameters which you can explore. So it depends from zone to zone, and you can always decide on your set of explanatory variables. So this is the attraction model. Then in the acquisition model, determines the zone from where commodity and quantity goods flows are originated. Again, this is a linear function of employees in retailing and activities and shop density. So one is attraction, how many goods are attracted, and the other is how much commodities are attracted, how much is the acquisition, which actually determines from where we are getting those commodities. So this ensures the determination of quantity OD flows. So we both have attraction and acquisition, which is like trip generation and trip attraction, and then from there we can generate the OD flows same as earlier. And once we have done the OD flows either by a gravity model or by a destination choice model of some sort, then we can actually convert quantity to vehicle, and so commodity OD flows are converted into vehicles. So this is a big step, which is an additional step from the previous model. In truck based model, we don't have to convert into vehicle flows because we are starting with vehicles. Over here we have to convert the OD flows into vehicle flows, but the estimates for OD flows are much better than the estimates for trip. And then what are the different types of freight that we considered? It could be agriculture and food products. These are the different categories for which we can model separately. That means construction materials, manufacturing products, oil products, maybe garbage, that is waste management, home accessories, stationery, clothing, building materials, household and personal hygiene, other goods. So you can see we can divide the entire freight type for different sectors or for different industries or for different purposes as well. So this is similar to modeling, like for different trip purposes, we are also modeling for different freight types. So both gravity type models and random utility acquisition models, like location choice models, like using multinomial logic models, are formulated for estimating commodity OD flows, and then quantity of OD flows are converted to vehicles. How do we do that? The different factors which actually influence the vehicle load composition are the shipment size, the transport service type, vehicle type, and the restocking journey. Is it a round trip or it's a trip chain? That means several trips would be there. And shipment size basically depends on the freight type and the receiver type. Is it for a shop? Is it for a supermarket? Like if it's for a supermarket, of course the quantity would be much larger. If it is for a shop, it would be smaller. So that is the shipment size. Vehicle type depends on freight type and transported quantity. Structured choices we can also use these nested logic models, where we can first determine on the carrier and the vehicle. So instead of just doing a vehicle choice or a carrier choice, we can say we can do a joint model of we select a carrier. Carrier means it could be a personal private carrier, or it could be a common carrier like a logistic company, and then depending that we can also determine a vehicle choice, because if I use my personal carrier, my vehicle may return empty, because that will factor in my freight movement flow. But if I use a carrier which is like a third party logistic, probably the probability of the vehicle which is actually doing the delivery returning empty is very less. So that is why this carrier choice also influence the kind of traffic load that is generated. And some carrier choice, then we can also look into the what kind of vehicle has been used to also by this particular carrier. So this could be a nested logic model, and again as earlier this kind of models, regression models, has to be developed based on actual survey values. So utility of an alternative for this particular models are like based on characteristics of the customers. Customers in this case are maybe the shops, maybe the shopping centers, maybe our distribution centers, and so on, and the attributes of the commodities, and for what type of commodity that we are determining these choices. So this is similar to our the choice models that we have earlier, where for mode choice models we were depending on customer characteristics, the journey characteristics, and so on. So similarly we also need to do the same things for freight as well. So vehicle OD matrices are different from quantity OD matrices, that is understood. Single vehicle can move through different destinations in the same tour. So that is why OD matrices are not same as the vehicle matrices, because the vehicle can take a tour and can connect between different drop points, or and it can go to different shops in one tour, and so that means this OD matrix and the vehicle matrix will be totally different. So because and we will adopt a tour based approach, and disaggregate modeling approaches are preferred in this kind of modeling process. So finally we come to one example. This is freight sim, where it's a model developed in Florida, and it's used for Florida freight supply chain. It's a intermodal model. And it's a commodity based model, so it's a little bit different from a 4-stage sequential model, which is usually primarily used for trip based models. So it's a commodity based model, and here commodity flows are assigned into different freight transport modes, and then the model includes a database of multimodal network of rail, transport, ports, highways, and distribution center locations at the national and geographical level. So this shows you that whenever we have to run this kind of models like a freight model, we not only need to know the data on the network, but we also need to know data on network means road on the links and the nodes and the capacities and so on, but we also need to have data on the distribution centers or the location of other freight terminals, because those are also part of my transshipment process. So in the next lecture, maybe after that, we will discuss on transshipment as well. So in transshipment, you will see that at the total tour is actually starting from one point, and then the delivery is another somewhere else, but in between there are also transshipment points like warehouse. So all these things actually play a role in the determining what kind of supply chain and resulting cost for deliveries, and that is why this kind of freight models are different from normal passenger models. So routes are optimized based on farm sizes, locations, cost, economic activities, and this is where this transshipment problem or transportation problems comes in. So these are linear models, linear optimization models. We will discuss that in later lectures. So this is where we minimize the cost, like which route we should take, or what choice of vehicle and route we should adopt for a particular delivery. So these are this has to be solved using optimization. Then captures the driving forces in freight demand change and is able to reflect the freight movement in real world. The model can be used for testing different scenarios for investment in highway rail. So it is policy sensitive. It can predict the actual movement of freight in particular in this kind of settings, and routes are also based on optimizing. There is a module for optimizing the routes as well. So this is the logistics part. So we have a travel demand model which determines what kind of flows are there, where it goes, but then there is the optimization model which actually improves those vehicle loadings or actual freight flows in a particular network. So these two are combined together to form this kind of freight model. So just to go through this, firms are initially synthesized, then supplier buyer linkages are identified, then goods distributed to supplier buyer pairs, then distribution channels identified, is it direct or intermodal, then shipment size and type identified, modes identified, and finally network assignment using equilibrium framework. So these are the steps in this particular model. So these are some of the references you can study. To conclude, this lecture covers different approaches for modeling urban freight along with their advantages and disadvantages. While truck-based models can be built relatively easily due to ease of data collection and calibration, they are not appropriate to use for forecasting analysis. Commodity-based models follow the fundamental mechanisms underlying freight transport demand, but are difficult to implement due to reluctance of private operators to share their business data. So in absence of data, we have to go back to this truck-based models, but these are not that good for predicting future scenarios. While developing these models, care should be taken to include relevant policy variables so that we know what would be the effect of our policies related to freight management. Thank you.